Okay, question 2. Last week, Len spent $18 to bowl 4 games. This week, he spent $27 to bowl 6 games. Len owns his bowling ball and shoes, so he only has to pay for each game that he bowls. If each of these bowling games costs the same amount of money, what is the constant of proportionality between the money spent and the number of games played? Okay, couple rules on this one. First rule, the constant of proportionality, strange term, comes up here and there, is the rise over run on a graph. The constant of proportionality is the rise over run on a graph. But look at here, we don't have any graphs. We just have an equation. So we don't even have an equation, we just have a relationship. We have $18 to 4 games and $27 to 6 games. So what are we to do with that? Another rule that's just good to know is generally money goes on top. So in a equation, it would be money on top, or in a proportion, it would be money on top. Something else like pounds or time or games here, games on the bottom, and that would translate to money on the y-axis and some other term on the x-axis. And here, time on the bottom. So it would be hours on the bottom and some other term on the top like miles per hour. Miles would generally go on the y-axis and hours would go on the x-axis because it's money on top, time on the bottom. So that's your general rule. So okay, here I put these rules together. You have money on top and you have constant of proportionality is rise over run. Well, then I'm going to conceive of this question as dollars per games, right? And I'm going to find out my rise over run or my constant of proportionality with dollars per games. I'm going to have dollars on the top or dollars on the y-axis like we talked about. And if I use proportions to tell me how much rise I'm going to get for every run of 1, well, that would be $18 per 4 games. Remember, dollars goes on top. We'll cross multiplication and division. 18 times 1 divided by 4. Plug that in your calculator, you're going to get 4.5. So that would be 1 game is equal to $4.5. And here, let's just see if it's the same. Another cross multiplication opportunity. 27 times 1 divided by 6. Yes, do that in your calculator, and again you will find it equals to 4.5. So for every game, and we're told that all the games cost the same, for every game you're going to pay $4.50. You're going to rise $4.50 for a run of 1. So you're going to rise, if you think of this as rise over run, you can think of this as rise of 4.5 over a run of 1, which equals to just 4.5. So that's your constant. Every iteration of 1 game is going to cost you another $4.5. So every iteration of another game is going to cost you another $4.5. That's why it's a constant, and that's why 4.5 is the right answer. And we're good.